Okay, so I'm going to try to get you up to speed on basically setting up the model for the final project in HyperMesh, because I know not everyone has a ton of experience in HyperMesh, although there are definitely individuals in class that do. So I'll take you through this really quickly. If you have questions, please, you can send me an email or ask some of the other students in the class. So we load up HyperMesh, and I'm going to be running this as if we're going to use Nastran. So I'm going to set my preferences to be Nastran. So this is going to support basically the model development for a Nastran model. All right. So the first thing we'll do is we'll bring in the geometry. So up here, there is an icon for various types of imports. You can import a finite element model, other types of HyperMesh models, but we're going to do geometry and IGES file, because I gave you the IGES file. If I didn't give you the IGES file in NX, you can just write out the IGES file. And you go in here and you pick the file. You have to maybe look for it a little bit. I already kind of did it, so it showed up right here. And then hit import. And now it's going to import in the geometry, okay? So here's our geometry. It did, I don't know, it's got an extra little block down there. And some of these things I do not need, but so be it, right? So here you can see the solid geometry, all right? So I like to go back to model. And again, I always recommend, although you don't have to do it this way, but I recommend the approach of defining materials, then defining the properties, and then actually then doing the elements, okay? So in this model, we'll use actually two materials. We'll use aluminum for the structure and steel for some of the fasteners for the connectors. So when we're in this model tab, I usually just right click on here and do create material. So let's make aluminum, right? And oops, so when you do that, you'll see the properties are down here. So Young's modulus for aluminum is 10e to the 6th. Poisson's ratio is like 0.3. The density is 0.098, but remember we have to do this in inertial units, in slinches. So it's 0.98 pounds per inch cubed, but divided by 386 inches per second squared, right? And so that's usually a big number, but I mean a small number, but let's do it, okay? Oh, my stupid calculators. Right. Yeah. Hold on 1 second. All right. My calculator's acting weird. Oh, come on. I'll put it over here. So 0.098 divided by 386 is going to be, I think it's 2.54 to the minus 4th, right? So we'll put in here 2.54 e to the minus 4. That's pretty much all the properties we'll need. If you want to put in damping, we can put in the critical, the structural damping ratio in here, like 0.005 or whatever we'll deem it to be, as we'll talk about. So there's the aluminum. We can also do steel, right? So we can do steel. Another material, steel. And steel has 30e to the 6th is Young's modulus. 0.28 is Poisson's ratio. And density is actually it's 0.28 divided by 386 is also the density. I think, right? 0.28. And that's 7.25 to the minus 4th. 7.25e to the minus 4th. Whoops, come on. 7.25e to the minus 4. All right, so we have our material set up. You can even give them a little different colors if you want to be able to make sure what's defined where. Next, let's define the property for the shell elements. Most of this is going to be shell elements, so I'll do that. So I'm going to define a property. Same way, but instead of picking material, I do property. This will be the 16th shell, and that'll be for both the angle bracket and the C channels because they have the same thickness. Okay, so it's a P shell card. All right, we can specify the material. This is going to be all the aluminum. So if I click material, I get this little selection menu. So I'll pick the aluminum. So it'll assign that. We have to put a thickness in. So 0.06 is the thickness. And again, for Nastran, we also want to assign a material ID 2. That's going to give you the bending stiffness, the shell element bending thickness. The material 1 gives you the in plane. So usually you specify both. Okay. And right, there you go. Okay, so that looks good. I guess it puts it for all of them. I'll double check. I think these are just the options. So I think I can just leave it this way. It'll automatically assign. If I don't do anything else, it'll assign this material to at least the first two material ID selections. Let's check. Like I said, we can right click on this and do card edit. And now you see the Nastran card. And yeah, you see it assign material ID 1 for the first material ID, which is the in-plane plane stress response. Also for the second one, which is the bending, as well as for the third one, which is the transverse shear. So you can disable that if you want to, but we'll just leave that as it is for now. And fine. So now we're ready to start making elements. Okay. So let's first do like this bottom bracket here. Okay. Now, if you look at this, you'll see that these are solid geometry, and I want to mesh the midplane. That's the appropriate place to mesh. So we have to generate the midplane. Okay. This is done very easily in HyperMesh. So if we go to geometry and highlight this button down here, so we're looking at geometry options. I think also you can do it up here in the menu. And you can do create mid surfaces, okay? Or we can also do it through down here if we do geometry mid surface, okay? And we'll do auto mid surface works. And the easiest thing to do for this geometry is just to pick solids, pick that bottom solid, extract. And now if we look closely, you can see what it did was it generated a mid surface, and that's what we want to mesh. It also created a new layer where that mid surface is, okay? So if we turn off like the geometry for the lower angle, you can see all we see is just that mid surface, all right? Okay. So now we can mesh that. So the easiest thing again to do is to just go to 2D panel here and do auto mesh and just pick these surfaces. An element size of 10 inches is probably a little too big, but let's try 0.125. Let's do a 1/4 inch. That's probably not too bad. Let's see how that looks. Wait, why is that 0.25? Okay, let's mesh. It's not too bad, but you know, probably could do a little bit better down here. I think we can go with a finer mesh. So we'll change. Let's try an 1/8 and recalculate all. Let's mesh and see how that looks. You know, that's not too bad. And if you wanted to and put more around this hole, you can probably put 8 around all the holes, and then you'll get a little better mesh there if you want. So I'm just clicking on this number. You can see it changes that. I know I'm going fast, but I got a lot of stuff to do today, and also I think a lot of people have already seen this stuff before. So, and you can pause it on the videos. So let's mesh again, and I did a little better on the holes, and that's fine. So okay, so return, and there we go. There's our finite element mesh. I can shade it in with that little button, and that looks pretty good. All right. Now what you'll see though is actually when it created that on this middle surface layer. So, you know, I like to keep things organized. So, you know, you can move it onto this lower angle level and we can do that. So that's usually through tools and organize, and we're going to move elements. So we're going to move them to the lower angle, and now let's pick the elements. So we'll pick the elements actually by collector because we can pick them on the middle surface. There they are, and now we move them, and now they're on this lower angle level, okay? And if we can change the color here, there you go. So that shows them on the lower angle, like collector level, so it just makes it a little easier to manipulate. Now, when you look at this lower angle collector, you'll see that there's no property assigned. So we want to use that 16th shell thickness property. So I'm going to click here, and again we get this little property window, so we can pick the 16th shell. And now that means that all these elements will be assigned that property, which is what we want to do. Okay. All right. Now you could go through and mesh the other shapes in a similar manner, and you know, maybe I'll pause here and I'll load up. I'll do that and then come back. I'll do the cooking show trick, right, where we take it out of the oven. And we'll lapse to there. So you know, that'll work. Well, let me just do another one. Then we can do a weld, and that's pretty good. And that'll get us there. Let's do also this C channel. Okay. So we have to again generate the mid surface on here. So we'll go to geometry, mid surface, auto generate, and we'll extract it off of that mid surface. I mean, off of that solid. So here you go. Here's our mid surface for that one C channel. You know, honestly, it's probably easy enough just to generate it on all these at one shot. And actually, you can see it generated all those mid surfaces. It put them on the mid surface level, so we can toggle off the geometries here. So I just see the mid surfaces. I think that'll work. And then the upper bracket, upper angle. So I think now I will just see the mid plane surfaces, but I also have these blocks, so let's turn off these blocks so I don't have to look at those. And the screws. There we go. All right, so now we can mesh this. Again, we'll do it the same way. Go to 2D, auto mesh. We can pick those surfaces. And come in. We'll be visited by Dr. Nazarian.
Hello, how are you?
You're being videotaped, just so you know.
I didn't do it.
See, you're on the camera.
What's it looking
Do
like?
you have a couple of minutes?
Well, I do, but let me pause this, okay?
Sure. I think the RFP that.
But no, like I said, I'm seriously live streaming, so it's fine with me. But say hello to Dr. Nazarian. Okay, we'll pause here.